Hey guys, I'll walk you through a series of diagrams to build up your understanding of off-grid solar systems. We will start with a single panel and a small inverter. Next, an inverter charger with a generator backup. Finally, a large system with a hybrid inverter. I'm curious to hear which system piques your interest for a deep dive. Leave a comment with your pick, and I'll provide a detailed explanation, including how to calculate the correct wire and fuse sizes, and the reasoning behind each component. This system can be used when you go camping to run a few lights or a TV. Here's a breakdown of each component and what it does. The solar panel is where it all begins. The solar panel collects energy from the sun and converts it into direct current. After the solar panel produces energy, the electricity flows through a circuit breaker. This safety device can be manually turned off to isolate the solar panels if you perform maintenance on the system. Next is the charge controller, a device that regulates the flow of electricity to the battery. It ensures the battery charges efficiently and helps prevent overcharging. The battery will get damaged if you don't use a charge controller. There are two types of charge controllers, PWM and MPPT. The battery stores electricity for later use. It saves the electricity you produce during the day to use when the sun doesn't shine. The type of battery, a lithium iron phosphate battery, is efficient, long-lasting, and can store a significant amount of power. I made a video explaining why lithium is cheaper than lead acid. Every wire is protected by a fuse. Much like the circuit breaker, a fuse is a protective device that will blow or cut the power if a current is higher than expected, preventing the wires from melting and possibly setting the insulation on fire. The fuse protects the wire, not the device. The inverter is a device that turns the DC electricity from the battery into alternating current or AC, which most household appliances use. The inverter in the system can provide a continuous 600 watts of power and can handle a short surge of up to 1200 watts. 600 watts is not enough to power a fridge, but it's enough to run a TV, a few lights, a laptop or a fan. In a nutshell, the sun shines on the solar panel. The panel makes electricity. The charge controller puts the electricity safely into the battery, and the inverter then converts that stored power into something you can actually use. This is a system I'm drawing for a client of mine who has a cabin in the woods. It uses a generator to recharge the batteries when solar isn't enough. Let's walk through the system. We have two solar panels connected in series. This adds up the voltage while the current stays the same. It's still under the 150 volts input limit of the charge controller. Wiring the panels in series will reduce the voltage drop. Thus, you need less thick wires to cover the long distance. Wiring in parallel is not a good idea, only when you have shading or use a PWM charge controller. Similar to the smaller system, there is a circuit breaker connected to the solar panels. This device will cut off the electric current if you want to do maintenance on the system. A place where you can turn off the power from the solar panels is required by the electrical code. The Victron charge controller manages the electricity from the panels, optimizing the battery charge and protecting it from overcharging. MPPT stands for Maximum Power Point Tracking, a technology that gets the most power from your panels. The battery is 24 volts lithium iron phosphate. It has a higher voltage and more capacity than the battery in the previous system, meaning it can store more energy and provide power for longer periods. Increasing the voltage of your battery allows for a cheaper charge controller, cheaper wires, and a cheaper battery charger. You're only allowed to have 3 connections on the main battery terminal. If you have more connections, you need a bus bar. Next to the charge controller is a Victron Multiplus inverter charger. It converts the DC power from the battery into AC power for your appliances. It can also charge the battery when connected to AC sources, such as a generator or grid power. This box is an AC distribution panel with circuit breakers for distributing the AC power to different outlets or appliances in your home. The backup generator is used if the solar panels don't produce enough power due to weather conditions or high energy demand. The generator can provide electricity to charge the battery, ensuring that you always have power when you need it. This system uses a hybrid inverter. A hybrid inverter is a combination of a charge controller, inverter, and a charger. It's also called an all-in-one system. Advantages are reduced wiring and easier setup. However, the drawback is more idle consumption. This means that the hybrid inverter will draw more power from the batteries just to be on. You must keep this in mind when you make your load calculation. We have two large arrays of solar panels, each consisting of 8 solar panels in series. With more panels, the system can generate enough power to run a home completely off-grid. The maximum input voltage of the hybrid inverter is 480 volts, and it has 2 separate MPP trackers, perfect for connecting 2 solar arrays. We don't need a combiner box or a solar disconnect switch, because it's already integrated on the right side of the device. The all-in-one inverter charger combines the functions of a charge controller, inverter, and battery charger. It converts the DC electricity from the solar panels to charge the batteries and then into usable AC power for household needs. It can also recharge the battery bank when connected to an AC source like a generator or the grid. A plus about this all-in-one inverter is that it has fuses and breakers that have already been installed, so we don't need to add them. Below the inverter charger are 4 lithium server rack batteries, enough for 20 kWh of storage. These batteries were chosen for their cost effectiveness, efficiency, and longevity. They should cover 2 to 3 days of powering your loads without sunshine. This is called days of autonomy and is a safety factor. To the right of the inverter charger is an AC distribution panel. This houses the system circuit breakers and is where the AC power is distributed to different circuits around the home, allowing for organized power management. The backup generator can run on gasoline or propane, offering flexibility. The generator serves as a backup to provide power to charge the battery bank during times when the sun doesn't shine, most of the time only used in winter. Tell me which system you want to learn more about in the comments. I will explain how to pick the right wires, fuses, and parts. Subscribe to keep updated when I post the in-depth video, and watch these videos next.